नमस्कार मित्रांनो, टुडे वी आर गोइंग टू लर्न लास्ट topic of the DC circuits module. The topic is maximum power transfer theorem. So, what is maximum power transfer theorem? You know, in a power system or any electronics and communication system, we need to transfer the power from source to the load, and we want to extract the maximum power. Okay, so for this we have to satisfy some condition. Okay, that condition we have to learn in this maximum power transfer theorem. So any complex network, you know, is given electrical network or electronics network, and the load is connected to it. So we will draw it first. So this is any complex network. At the two terminals of this network we are having the load. So the basic aim is what? This load should consume the maximum power from this complex network or sources available in that complex network. So the statement is, whenever we want to transfer the maximum power, that is to this RL, you can say this power is PL. Okay, so power consumed by load, that is PL, is maximum when this load is equal to the equivalent resistance of this complex network. When this load must be equal to equivalent resistance of this complex network, provided that resistance can be calculated when sources are replaced by their internal resistance. Just extension of your Thevenin's theorem. So whatever steps we have to follow of Thevenin's theorem. So इथे मी आता Thevenin's equivalent circuit draw करतोय. The complex network can be converted into Thevenin's equivalent network. As per the Thevenin's theorem, the current flowing here is IL, and this IL is given as IL is equal to VTH divided by RL plus RTH, or RTH plus RL, and the power of this load is nothing but IL square RL. Power is given by IL square RL. VTH divided by RL plus RTH, the whole square into RL. This is your PL. Now our aim is to find condition so that this power will be maximum. Now what is variable here? RL. So we have to differentiate this PL with respect to RL. We have to differentiate to RL and compare it with the 0. So DDRL of your power must be compared to 0. So we have to compare the derivative of this power with respect to 0, and further you can solve. You will get the condition at the end as your RL is equal to RTH. This is the condition we will get after solving this derivative. Okay, that means whenever load becomes equal to equivalent resistance of the given network, then that circuit will give maximum power to that load, or that load will consume maximum power from the circuit. So here we have derived the formula or the condition RL is equal to RTH. Then what will be the P max? See, formula for PL we have written as what? IL square RL. So it is nothing but IL is what? VTH divided by RTH plus RL. Okay, whole square into RL. Now as per this condition we have to substitute RL as RTH. So this will become VTH square upon RTH plus RTH. So 2 times RTH whole square into RTH. Okay, so VTH square upon 4 RTH square into RTH. So this square will get cut, and the formula for PL max will be equal to VTH square divided by 4 RTH. Okay, this is the formula for maximum power transfer. VTH square upon 4 RTH. Okay, now we will solve one numerical based on this theorem. Okay, here the question is find RL to get maximum power and also find max power. Okay, so here all things are given except RL. We have to find the RL, that is nothing but we have to find RTH, so that RL is equal to RTH. The steps here we have to follow are same to your Thevenin's theorem. Okay, to find VTH. To find VTH, what is the step? We have to remove RL from the circuit and we have to open that 2 points. Okay, so I will redraw the circuit. Okay, 100 volt, 40, 60. See here, these 2 volt will not belong to any mesh. This is just hanging voltage. Okay, you can say this voltage will not come in a mesh, but that we have to consider at the end whenever you are finding VTH between these 2 points X and Y, or we are tracing that circuit so that we will get the VTH value. Again we will apply mesh. Here there are 2 mesh. This is my first mesh which will give me I1. This is my second mesh which will give me I2. So solving this mesh 1, apply, what I will get? 100 minus 40 I1 minus I2 minus 60 I1 minus I2. So 100 plus 100 I2 is equal to 0. See here, 100, 40 and 60 I1 सोबत सुद्धा आहे I2 सोबत आहे. So 100 I1 आणि जर आपण 100 कट केले it will be 1 minus I1 plus I2, or rearranging the term I1 minus I2 is equal to 1. Okay, this is my first equation for mesh. This is my first equation for mesh. Apply KVL on mesh 2. We have to apply KVL to mesh 2. So it will be plus 100 I1 and 100 and 100 200 minus 200 I2 is equal to 0. There is no voltage source in this mesh 2. So I1 minus 2 I2 is equal to 0. This is my second equation. Solving 1 and 2, what we will get? Here we get I1, both are clockwise. Hence, now we can find our VTH between point X and Y. VTH is equal to VXY. Okay, so we can trace from anywhere. Okay, इथे करंट काय वरून खाली येतोय. Okay, इथे करंट खालून वर जातोय, but that is the difference between I1 and I2. Okay, so VXY is equal to what? Minus 2 minus 50 I2, as I am flowing from plus 2 minus, minus 60 I2 minus I1. Solve this. It is 8 volt. So this is my VTH. VTH is 8 volt. I have got the first answer. Now second step, to find RTH. Step 2, to find RTH is my step 2. So what is to be done? Voltage source is shorted. So इथे काय राहतं आपलं, हा शॉर्ट झाला, याच्यामध्ये दोन रेजिस्टन्स आहेत 40 and 60. ओके, हा माझा X, हा माझा Y, तिथे काय राहिलं 50 आणि 50. Okay, X and Y, then this point you can consider Z, so Z will be there, Z. Okay, everywhere we will get Z because it is shorted. See, shorted, so Z is there. So only 3 points are there, x, z and y. X, z, y. So I can put the values x and z च्या मध्ये 60, x and z च्या मध्ये 40. So one resistance of 60, one resistance of 40. Then z and y 50, 50. Okay. 50, 50 and this 50. So we will get the parallel combination of two resistors, and that will give me my final answer RXY, which is nothing but RTH. It gives me 49 ohm, and therefore as per maximum power transfer theorem, your RL is nothing but 49 ohm, and that is my first answer. So VTH we have got RTH, and the final answer, that is RL is equal to 49 ohm. And again the question is to find PL max. So maximum power is equal to VTH square upon 4 times RTH. So VTH we have got 8 square divided by 4 times 49. So that will be my maximum power, 0.326 watt. Okay, so that ends your DC circuit module. In next videos we will start new model. Thank you.